Okay, welcome back. This is video number 7. We will be adding capabilities to save gyro properties into memory, specifically calibration and maybe some other stuff. But for now, we just need the capability to save calibrated data into memory. So when the unit powers up, it'll be fully calibrated. We can see that we see the parameters for calibration, but it wouldn't do much if we calibrated this, because as soon as we remove power, it'll be gone, so nowhere to save it. This video would be adding that functionality to our BNO class. In reality, this code should be in its own class, but we're just going to add it to the BNO class. Okay, so what we need a way to reset memory. So if it doesn't have anything in it, we want to minimum have zeros in it, so when we do our calculations it doesn't screw up our code. So for that we will need a reset memory function. We need a way to read memory, and this one is going to have a parameter for the data that we're going to read, where we need to store it. We also need the size, or how many bytes we are reading, and the location of this memory. The next one is writing or saving to memory, and this one has the same signature. Takes the data we are saving to memory, the size, a location, or a storing location. So we also want a variable, a member variable, to store that memory. So this will be memory settings, and we know at a minimum we need 22 bytes for the calibration data. We might need a little bit more than that, so let's just make it 32 to be safe. And since we need to know the size of this at any given time, and this might change depending on our requirements, we don't want to keep calculating this, so we'll create a variable to hold the size and be calculated once. So size of settings will be size of memory settings. Okay, that's all we need. So let's start by writing that function in our BNO CPP file. Reset memory, and on this one you want to read the memory we have already. And I know this class hasn't been defined, but we have the signature, so we can just assume that the functionality will be there. And the data we read, we will put it in memory settings. The size will be size of memory, and location will be 0. So when we reset it, this is not just to call it reset it. This is just so when we run it, we always want to make sure that it's reset only once, and after that we don't reset anything. So we check to see if memory settings, the first byte is, let's say we want to check if it's equals to capital I. If it's that, then that means it has been initialized, or actually it shouldn't be reset, it should be initialized. So let's call it init. Okay, and then we'll return if it's I. If it's not I, we need to write zeros to it, so we initialize the memory with zeros and it doesn't have null values or unknown values. And we want the first byte to be equals to I. So that way we'll write it and then we won't have to initialize it the second time. Once we have this, we can write to memory. And same as before, this hasn't been created, but we have the signature, so we can safely assume that this will work. Okay, so we're reading the memory. If it's I, we exit. If it's not, then we define a local variable with brand new second memory, and then we just write it. And the new second memory has all zeros. That's what this means. Now reading the memory. So write this first. So when the size location, and for this one we want to convert location. Like this. I want to convert location to 8 bytes or multiply by 8 because we're going to read and write in increments of 8 bytes or a 64-bit number. We create a loop. And check the index is less than size, so that's how much data we're going to be writing. And then index incremented by 1. And reading data is pretty straightforward. You just point directly to the memory location and grab whatever value is there. So we say data index equals, and come on. So this file, what page is this? 54. So this RM0454 is a reference manual for STM32G0, which is the one we're using. And in page 54, or somewhere there, where is it? Memory access, there we go. Listening to the it, is it here? Memory. I lost it. Oh, I was in the wrong one. It's flash memory, sorry. Apologies. So that's not it. Where is it? Right here. Is it here? It's not. Must be up there. My memory locations. I lost my page. My reference. Here it is. Okay. I guess page 54. So these are the addresses we have, and it starts from page 0 all the way to for devices that are 128K, which is the one we're using. Last page 63, and we are going to use the last page to write our settings. The page is 2K in size, or 2000 bytes, and this is a starting location, ending location. So we need starting location, and that's the where we want to get our data, and then we just increase it by 8. This one needs to be converted to a 64-byte, and also it needs to, we're getting whatever it's pointing to. And lastly, this is not really required, but assign it, but we're going to do it anyways. Okay, so that will give us, that will read whatever data we want. So when this calls, it'll populate, look at here, whatever number this is, and it'll start at 0. and then we'll go from memory's location or the base memory here. It's going to increment it by 8 and then go grab the next one, and then it'll go on and on. So next function, write memory, assign data and size, location, and I'm gonna write first the bare minimum for writing to memory, and then we'll change the function to do what we want it to do. So it's just the bare minimum in case you're wondering how to write to memory. So first you need to create instantiate a structure of flash erase init type definition, whatever that means. So it's going to be we're going to erase a page, so we'll call it ePage, and ePage type erase will be flash type. It'll be type pages, and the page will be the last page, this page 63, and then we need to specify how many pages, and it'll be 1. We will need a variable for errors, set it to 0. We also need a status for returns, and we unlock the memory. Before we can do anything, we need to unlock it. Then we erase the page. That's not it. Page and error. Okay. And we do a loop like before. So index 0, index less than size, increment index by 1, and we say location 8. And we're programming Flash, so the type will be double word or 64 bytes. The address will be the same as this, and actually it'll be exactly the same. And the data will be whatever's in index. And now we just increment location by 8. And last, we unlock equal sign. I'm sorry, we lock the memory, not unlock. So that's the bare minimum. You need to erase a page, so you create your structure, fill it up, unlock memory, erase your page, and then go and populate your new data. This is the bare minimum, but we need something better because we want to be able to write individual bytes at any given time without erasing everything else. So to do that, we will read first what we have in memory. We'll save it to memory settings. It'll always be location 0. We want to put some safety code just to make sure the size it doesn't go over what we're trying to do here. So size of settings. So if size is more than size of settings, then we'll just keep whatever size of settings we have. Otherwise, size is good to go. We'll do the same for location. But on this one, it has to be at least 1 less than size of settings. Size of settings. If it is more or equals to it, then we want size of settings minus 1. Else, location is good to go. Now that we have what we currently have in memory, we want to replace those bytes which we're bringing in. So the new bytes are going to replace existing data, and then we can write the entire page again. So we'll need a loop here. Okay, increase it by 1. And we want memory settings, location, and then we increase it by 1. Data index. Okay. Also, since we are going to be increasing location, we always want to check again to make sure that it doesn't go over what we're trying to write here. Obviously, we don't have any safety stuff here, so if we go read more than what is available, it'll crash, but that's okay. This is our code, so no big deal. Just on the right hand side of it, we want to play it safe a little bit. Because if you write to the wrong side, place in memory, it will give you errors, and it will be difficult to figure out what's going on. Reading, it'll just crash it, or it'll give you data. So, all right. So now that we have that, we want to write the data. So this is going to change a little bit. We don't need that. We don't need that either. And on this one, instead of size, the size of settings. And here, it will be index multiplied by 8. And the data will be whatever memory we have plus whatever is being changed. So let's compile, make sure everything's okay. Have some errors. First error is this. Is that the first error? So what is this complaining about? Location was not declared, so this is just a typo. Compile again. All right, no errors. So we'll go to our main function, and we're gonna load. Well, before we load it, let's go read whatever we have in memory, and we'll read it. Data, the size will be, let's say 2 bytes, and the location will be 0. All right, so let's see what it does. Actually, before we do that, this should be when we initialize the class. So we'll put it here, and every time the unit boots up or powers up, it'll call this, and obviously it'll read it, check to see if it's I. If it is, it'll return. If it's not, it'll populate everything with zeros and set it to I. All right, so let's display this. Log I, and let's put mem status equals, and say data 0. And let's put a delay of 1 second. Comment this out, run it, and this is the previous code from last video. So it'll pause and it'll go really slow once a second, but we should get whatever value is, I think it's 73. If it works, obviously. And download and verify successfully. Something didn't go through. Let me run it again. While they're waiting. Oh, okay, I see. We didn't put the what I always forget, that. Right. That's why you see this here. It was sending data, it just wasn't telling it that that was the end of the message. Okay, let's see. There it is. So 73, which is the equivalent of I, that's the number for I in computer language. So we're good to go. Memory has been initialized. Now, one last test. We'll just let's write to two different locations of memory and see if the memory is kept. So first, let's go read some memory. We'll go read on light on memory actually. So let's start at location 1 and let's read 20 bytes. Okay, and we'll display, let's display 4 bytes, and we'll display 1 and 1, and then let's do 10 and 11. Okay. So let's see what we get when we do that. Let me move this a little bit to the side. Okay, so there's the code. Over. So there it is. Those are the 4 bytes. They're all zeros because we haven't written anything to them. But if we write to them, write memory data size, let's write 2 bytes, and let's write this at location 1. So it'll start at location 1, and then we'll write another one. So we'll do 2 separate writes just to demonstrate that it's not erasing the entire page. This one is going to be at location 10 because we're displaying 0 and 1 and 10 and 11. Okay, so I think we'll be good. This might have to be 9 though. We'll see. No, it is 10. Okay, never mind. We're good. Okay, so data 0. This will be, let's put 65. And this one we'll put 66. And then right here we'll put 15 and 16. Right, so those are the 2 locations. One is writing it, you know, even though it's a 0 and 1, it's going to write to this location right here, 10. No, I'm sorry, that's the wrong thing. We're writing 2 bytes at location 10, and this is at location 1. So it's writing 2 bytes starting at location 1, so you'll write on 1, you'll write 65, on location 2, 66, and then on location 10, 15, and on location 11, 16. So let's call it, run it. I didn't switch the code, so this is what here's what I did. Nice for writing the first 2, writing the second 2 at location 10 right here. This one's at location 1. And there it is. So we have should be numbers, not characters. Sorry. Okay. I had them in single quotes, so we need to change it because we're writing numbers. So we want the 65, 66, 15, and 16. Okay, let's see what we get. So we got 65, 66, 16, and 0. So why 0? Well, let's figure that out. All right, we got 0 and 1. That means that there's probably a bug in this thing, because it's giving us the first one, it's giving us the second one, and then it's giving, oh, okay, it's off. So yeah, so it's off by 1. So this has to be 9 because the index starts at 0. So 0 base array, and this one is 10. And again, let me switch this back. So I had 10 here, and this one 11 is really 9 and 10 because it's 0 base index array. So now it should give us the right data. So we have the 65, 66, 15, and 16. So now even if we comment this out and compile it or remove it and compile it again, okay, so still downloading. There it is. So if we power this off, no power, so there's nothing coming across. You can see it's disconnected. Power up. Our settings are good to go. So now we can save calibration data. That will be for the next video. That's it for this video. I don't want them to get too long. This one's already long enough. So until next time, enjoy.